Without further ado, let me introduce our next speaker, Phalgun Kulkarni, speaking on Windows Search Index, the forensic artifact you've been searching for. Phalgun, take it away.
All right, thank you so much. Can you hear me? All right, okay. Thank you for taking the time out and joining my session. I will be talking about Windows Search Index and how it can enhance DFIR investigations. And I believe that is the forensic artifact you have been searching for. So let's get started. I am Phalgun. I work at Aon, delivering Strauss Friedberg's incident response and digital forensic services. In my role, I work on various cyber incidents such as ransomwares and APTs, and I love to come up with novel ideas to perform research and enhance DFIR as a whole. And she is my colleague, Julia. We have co-presented this talk at multiple conferences like SANS, HTCIA, Phalgun, BSides, but unfortunately, she could not make it to this one. Right, so why should you listen to this talk? We have been thoroughly researching Windows Search Index and have a good understanding of this artifact. We were amazed by the wealth of information we could recover from just a single artifact and wanted to share those insights with you to enhance DFIR investigations. By the end of this talk, you will be able to answer questions associated with files and folders present on a disk, metadata associated with non-existing files, as well as historical activity associated with the user's internet browsing activity, all from just a single artifact, Windows Search Index. All right, so let's set the agenda for this talk. I begin by introducing Windows Search Index and how it works. Next, we dive into what data is stored and how it's structured in the database. We quickly go over the changes introduced to Windows Search Index in Windows 11 operating system. Next, the most interesting part, and I'm sure you're going to love this one, is the forensic value held by Windows Search Index artifact. And last but definitely not the least, we showcase CIDR, or Search Index Database Reporter. It's Strauss Friedberg's open source tool to parse Windows Search Index at scale. So before I move on, I wanted to take a quick minute and explain what a forensic artifact is. So Windows introduces features which are aimed toward enhancing user experience. So let's say, for example, jump list can allow a user to switch between files quickly, and prefetch can shorten the startup time taken by an application. On the flip side, jump lists can be used to prove file access or file knowledge in DFIR investigations. And prefetch can also be used to determine whether an application was executed or not. So similarly, Windows Search Index exists on a system for users to be able to search for multiple files, but it can also be used as a forensic artifact, and that's what we are going to see. So let's get to know more about Windows Search Index. Windows enables users to search for multiple files or folders using the search box, which is located at either the taskbar or the Windows Explorer. But in the background, Windows Search Indexer service works to get results for your file search queries. And some Windows programs also use Windows Search Index. For example, Cortana. So it will query the Windows Search Index database when you perform some file search queries in Cortana, and that's how Cortana will have answers for you and it will pass on the information which it queries from Windows Search Index database. And similarly, other applications like Outlook and Photos will utilize the database for answering your file search queries. So let's see how this actually works. Let's consider a scenario where you want to access an Excel sheet which you created at some point in time, but you forgot where it's saved now. So you search for it in the search box, and then the search box will query that particular file's location in the Windows Search Index database. Now, before all this happens, the search indexer service will extract metadata for that particular file and store it in the search index database. And that's how Windows Search Index Database will be able to tell the search box that this file is located at this location, and search box passes that information on to you. And you are eternally grateful for Windows Search Index to be able to answer your file search queries. All right, so now that we know how Windows Search Index works, let's get to know what data is stored and how it's structured in the Windows Search Index database. So basically, metadata of files and folders from two directories, namely C users and start menu programs, will be recursively indexed, and that will be stored in a database. Now, this database can be found at C, program data, Microsoft, search, data, applications, Windows directory. So let's see how this database looks like. So beginning from Windows Vista until Windows 10, the database sits in an ESE, or Extensible Storage Engine format. And importantly, the Windows Search Index service will be enabled by default only on the Windows endpoint operating systems and not on the Windows Server operating system. So it will be on by default on Windows 7, 10, 11, but not on the server 2012, 16, 19, etc. So this database is named windows.edb. And like I said, it will be in an ESE format. So windows.edb contains multiple columns, but we have identified 3 to be the most useful from a DFIR perspective. And when I say DFIR, it is Digital Forensic Incident Response for folks who don't know what that is. All right, so let's begin with System Index Gather. It's short for GTHR table. So this table in windows.edb file will contain multiple columns. And again, we have identified 3 to be the most useful ones. We have the file name of the file or folder being indexed, as well as the last modified timestamp. Next, we have the scope ID column, or scope ID values, which is an integer assigned to every file or folder. And we can use scope ID to determine files or folders parent folder. Next, we have the system index gather path table. Now, this table only contains 3 columns, namely scope, parent, and name. We can correlate the gather and gather path tables to form a files or folders parent-child relationship. All right, now let's get into the meat and potatoes of Windows Search Index, also known as the property store table. Now, this is the most important table of all, and it will contain like all the important data from a DFIR perspective. Beginning with the search gather time. So this is the time when Windows Search Index will create a record of file being created or modified. So this will be another timestamp in addition to the modified access or creation timestamp. So this can be very useful in determining where if there was timestamping in question. We also get the full path and the file owner of the file or folder. And lastly, we get the most interesting feature, which is the search auto summary. What this feature will do is it will index partial file content. So it can be important for, let's say, if you are investigating a case and there is data exfiltration in question. If a data exfil tool was used and it uses a configuration file, you may be able to get that data or content of that config file without even having to access that config file. We may be also able to recover deleted information. And I will be talking more about recovering deleted information in the further slides. So again, the most important table, the property store table. So let's see how windows.edb file looks like. We use Nearsoft's EAC database view to open the windows.edb file. And as we can see, all the ducks are in a row. meaning that every entry or every record will be a separate row, and the columns will represent various file properties. Now, let's consider a scenario where you are investigating a Windows 11 operating system. Now, you want to parse Windows search index and you go search for windows.edb file, but you cannot find one. You ask why? Because Microsoft introduced changes to Windows search index in Windows 11 operating system. Now, the single windows.edb file is split into three SQLite files, namely Windows Gather, Windows, and Windows USNDB. Windows USNDB is still being tested upon and is out of the scope of this presentation. So again, basically all the data remains the same, but the format is changed from ESE to SQLite. So let's quickly compare how the change looks like. As you can see on the left side in Windows 10, all the tables are contained in a single database named windows.edb. But in Windows 11, the system index gather and gather path tables are stored in Windows GatherDB. And importantly, the property store table is split into two, namely property store and property store metadata tables. Again, information remains the same, but the format and structure are changed. So let's quickly take a look at windows.db file. As we can see, all the ducks are not in a row now, and every record may have multiple rows. So the work ID column will represent a unique entry or a unique record, and the column ID column here will represent values which can be mapped to their respective file properties. So let's say, for example, consider the value 13 in row 1, which when mapped to the property store metadata table, shows us that system is folder. And that's how we know the work ID record associated with work ID 1 is a folder. And similarly, we can map all the remaining column ID values to the respective file properties. Right. Before we move on to the fun part, the forensic value of Windows Search Index, I wanted to highlight few important points about ESE databases or ESE formats. So ESE databases are made to include file operations or transactions happening in quick successions, meaning that if a file is created, modified, and deleted fairly quickly, all that activity will be stored in the ESE database files. So you may wonder that whenever a file is created, that record will be immediately added to the database. But no, that is not how things work with ESE databases. So whenever a file is created, that record will be added to a log buffer or memory. And when this log buffer gets full or memory gets full, this data will be written to a log file, which will be stored on disk. Now, this log file in turn is applied to the database or ESE database or written to the database to capture all the activity which happened from the previous commit or the last time when this log file was written to the database. And this may not happen immediately. Like there are a few conditions for the log file to meet before it can write itself to the database. Meaning, for example, if the log file gets full or certain time passes by, then it may write itself to the database. Now, importantly for DFIR investigations, if we perform a live image or if there is a shutdown event or a BSOD, blue screen of death event, the log files may not be written to the database, and that will render the database in an dirty or in an inconsistent or a dirty state, meaning that not all the activity happened on a system will be included in the database. But there is a built-in Windows utility called ESENTutil, which we can use to either recover or repair the databases, meaning that we can make an ESE database from a dirty to a clean state. And we can use the flag R and P to either recover and repair the database files. Now, importantly, I would recommend you to perform the recovery first before performing the repair, because the R flag stands for recovery. And if you do P flag or try to repair the database, it may not consider whether the database is in a dirty or in a clean state. And if you want to use repair, just use the G flag, which will check for the integrity of the database, whether it is in a dirty or a clean state. If it's in a dirty state, it will pause, ask you if you want to clean it, and then repair the database. Another important point, if you have an ESE database from a Windows 10 system, and if you try to clean it on the Windows 7 system, that will not work. You should not be using Windows 7 now anyways, but keep in mind that the operating system from where the windows.pdb file is coming from should be equal to the operating system which you are cleaning the file on. All right, now enough with the boring part. There was a lot of technical information. Let's get with the forensic value held by Windows Search Index and the use cases where Windows Search Index can help us in DFIR investigations. All right, so let's see what Windows Search Index can tell us about files and folders present on a disk. As mentioned previously, metadata from the index locations about files and folders will be stored in the database, which can be found in the property and property store tables in Windows 10 and 11 respectively. So the metadata will include, but is not limited to, the full path, the modified access and creation timestamps, a file type as well as file owner, and importantly, the search index gather time. So again, this is an additional time which we get in addition to the MAC timestamps, and it will be the time when Windows Search Index creates a record of file being created or modified on a system. And this will coincide with the file's last modified timestamp. So again, you get one more artifact to check timestamping or cross-verify your timestamps if there is timestamping in question. You may wonder where this information can be useful. So for folks working in incident response may know that threat actors leverage directories present under C users to deploy malware or stage files. So we can even enumerate that. Oftentimes, employees download malware thinking it to be legit files. We can identify initial attack vector or initial access vector by exploring the downloads folder of any particular user. Sometimes malware threat actors deploy persistence mechanism by creating startup tasks. So we can find that in the start menu program's startup folder. And importantly, we can also recover metadata associated with deleted files, or if there was any activity associated with non-existing files. Again, you may wonder, why do I need all this information if I have a forensic image or triage data? Now, if you work in DFIR, you may know that sometimes we do not have full forensic image, or the triage data may not have all the directories indexed by Windows Search Index. And importantly, you do not need access to the file system to enumerate all these locations. It's there for you in just a single database. All you need to do is parse it. So isn't this amazing? All this information from just a single artifact. Talking about amazing features of Windows Search Index, I mentioned that it also records partial file content. So the search auto summary feature will record the partial file content of specific file types. You may think, is this feature built for us forensicators? It is not. The primary purpose of this feature is for users to be able to search for file content. So we tested by creating a text file and embedded the word pineapple in it and searched for the word pineapple. And as a result, the text file got popped up, and that's why Windows Search Index will contain the partial file content. But for us forensicators, it is a gold mine. We get the access to file content without even having access to that particular file. And importantly, for Windows Search Index to have that data, the file type must match the extension. So let's say if you have a text file and you rename that to the .pdf, or you create a PDF file, Windows Search Index will not be able to collect or record that data from that text file because it will be looking for a PDF file format, and that's where it will fail. But if you rename it from a .txt to .bat or batch files, Windows Search Index will be able to record the partial content because text and batch files are text format files. The file format must match the extension. And during our testing, we concluded that in Windows 11, file content up to the first 1024 bytes will be recorded, meaning that if a file is smaller than 1 kilobytes, you get the entire file content. And this can be really important in the investigations if a file is deleted or you do not have access to that file. Right, so you may have some questions about which file types are indexed with their partial content. We enumerated a list, and this is by no means an exhaustive list, but important from a DFIR perspective. So you may be excited to see ASP or JavaScript files, which can be malware dropped by threat actors. We also have documents and OneNote files, which are leveraged heavily to be acted as initial attack vectors. Like threat actors will include the doc files or OneNote files in phishing emails and compromise employees or systems in a network. Again, by no means is an exhaustive list. Like a lot of file types are indexed with their partial content, but again, this is just important from a DFIR perspective. All right, let's talk about recovering deleted file metadata and content. So whenever a file is marked for deletion, whenever a file is deleted, it will be marked for deletion and will not be immediately removed from the Windows Search Index. It is similar to that of deletion occurring on a Windows file system. And if we perform a live forensic image, we may be able to recover data associated with deleted files, like the full path or even the partial content of that deleted file. But if there is a shutdown or a reboot event, you may not get that data because the logs will be replayed to the database and the files which were marked for deletion may be deleted by the time after the system is rebooted or shut down. But again, there are a few tools like WinSearch Analyzer, which you can utilize to recover data or recover deleted files from even a dead box forensic image. I think this is a gray area for us, and in our testing, it was inconclusive. So at times, when we deleted a file and collected a live image, we sometimes were not able to get the deleted file data, even if it was not a reboot or shutdown event. At times, if that was a shutdown event, we were still able to recover that deleted metadata or deleted content without having to use the WinSearch Analyzer tool. So it really depends on various factors like size of the database, when it was shut down, how it was shut down. So that's one aspect where we are still researching, and that gets me excited about Windows Search Index even more. All right, let's talk about another interesting aspect of Windows Search Index, and that is the ability of Windows Search Index to provide insights about the user's internet browsing activity. So at times, investigators may need to enumerate browsing activity, but they may not have browsing artifacts at disposal, or they may want to cross-verify their findings. So Windows Search Index will record activity conducted using Edge or Internet Explorer browsers. One quick caveat here is activity conducted using private browsing mode will not be indexed. And interestingly, in Windows 10, we found out that successfully visited URLs meaning that if a site was visited with an active internet connection, or if it was a legit website, then it will be stored in the item path display column of the property store table. But if it was unsuccessfully visited, meaning that if the URL did not exist, like let's say, for example, 1234, this website does not exist.com, or if it was visited without an active internet connection, then it may be either stored in the activity content URI or activity description columns of the property store table. Now, in contrast, in Windows 11, irrespective of how a user visits or traverses a URL, that will be stored in the system link target URL column of the property store tables. In our testing, we found out that some of the unsuccessfully visited URLs may not be present at all in the database. Again, we are not sure why this is happening because it was inconsistent and we were not able to replay or recreate the same conclusions every time. Now that we know Windows Search Index also records the internet browsing activity, the question has to arise. What if a user deletes their internet browsing activity? Windows Search Index might save your day. So we tested by deleting the history from the browser itself, as well as by deleting the app data folder of Edge browser. That's where all the data is stored. And as you can see, we were able to recover the entire history session of that user, including the system, the web page title of the URL which was visited, the time of access, as well as the full path of the URL. Isn't this information amazing? You do not need browsing artifacts and you can recover deleted browsing activity of a user. How cool is that? It may not be cool to everyone, but it is cool to DFIR folks. All right, and in Windows 10, we had contrasting results. So deleted browsing activity was only sometimes present in the database. Again, we do not know why it was only sometimes present. We are still researching that particular aspect, but that's what we have concluded until this point. And some of the remnants or some browsing activity may also be present in the activity history feature. You may wonder, what is activity history? So let's talk about it. Right. Windows Search Index can also tell you when a user interacted with a file using which application. So activity history will track file interactions for a user. And importantly, if a file does not exist on the disk anymore, or if it's deleted, and if it was interacted with at some point in time, that record will still be present in the activity history feature. So you will be able to recover or enumerate any activity which was conducted, which may be associated with deleted files. Again, like how cool is that? You don't need to use any tools to carve out slack space of the database or the file system to identify if there was a file present on a disk or not. The way we identify activity history is by searching for the activity history item string in the system item type field. An important point is, if an activity is not present in the activity history feature, it does not mean that it did not happen. Activity history is a subset of the entire user activity. So that's one important point to keep in mind. And like I mentioned previously, some of the browsing activity will be present in the activity history feature as well. So let's see what exactly gets indexed in this feature. Let's consider an example. Like if I interact with a PDF file using Firefox browser, so the full path of the PDF file, including my SID or security identifier, as well as the start and end time or opening and closing time of the PDF file with the application or program used to interact with the PDF file. And in this case, the Firefox browser will be recorded in the activity history feature. So you will be able to tell what a user interacted, when a user interacted with the file using which application. We observed that activity history start and end times may vary by a few seconds sometimes. So not the most accurate timestamp, but fairly close toward being an accurate timestamp. So an important point to keep in mind. So we tested by interacting with few common file types and few common applications used by average users on a day-to-day basis. As you can see, the text format files when interacted with common applications like Notepad, WordPad, PDF files when interacted with common browsers, and our day-to-day files like Excel sheets, documents, photos will all be indexed in the Windows Search Index activity history feature. And again, Windows Search Index also records metadata associated with Outlook or emails related to Outlook program. So, but that is out of the scope of this presentation. All right, so let's see how this actually looks like when we parse the data from a forensic perspective. So we created a text file and interacted with using Notepad. And as you can see, the text file contains an IP address, so it's malicious. Right. And we use WinSearch DB Analyzer tool to parse windows.edb file. And we were able to enumerate partial content. And in this case, the file was very small, like less than 1 kilobyte. So we got the full file content without even having access to that file. And we were also able to enumerate the activity or the file interaction for that specific file. So as you can see, we get the SID or security identifier of the user who interacted with the file, the program used to interact with the file name itself, and the opening and closing times, meaning the start and end time of the activity. Again, all this information from just a single artifact. All you need to do is parse it. All right, let's talk about CIDR. CIDR stands for Search Index Database Reporter. It is our tool, open source command line tool to parse Windows Search Index at scale and effectively. So you may think like we already have WinSearch DB Analyzer. Why create another tool? So during our testing, we came across two major hurdles. One is that we needed to parse EAC database one at a time. We could not parse multiple databases at a time. And second, that is that we needed to use different tools to parse EAC and SQLite database files. So that's why we created CIDR. CIDR will parse both EAC and SQLite databases and at scale. So you don't have to parse each database one by one or use two different tools to parse database files. And importantly, it will output 3 CSV or JSON reports, which will contain most useful information from a large data set, which can be helpful in DFIR investigations. So you don't have to spend time extracting information from a large database file. It's very fast, written in Rust, and we have it open sourced on GitHub under Apache 2.0 license. You can compile it on your own system. If you don't want to do it, you can even download the Windows build, which is available on our GitHub. All right, so let's see how it works. You call CIDR, you give it the format option of the output you want, meaning that if you want a JSON output or a CSV output, JSON will be by default. Next, you give it the output directory. That's where the CSV or JSON reports will be generated. If you do not give this flag, the current working directory will be treated as the output directory. And help will print this message. Version will get you the version number of CIDR. And importantly, you need to provide a path to the input directory. Remember that it is not the path to the database itself, but the input directory, but the directory where the database files will reside. So that's how CIDR will be able to parse multiple databases at a time. Let's see how it works. So we run CIDR, give it the output directory, give the format and the path toward path where the input directory is, and that contains the EAC or SQLite database files. As you can see, it will generate three beautiful CSV reports. And if you parse multiple ESE or SQLite databases files from multiple systems, we have it named in such a way that you will be able to differentiate those different systems. So we have the host name of the system. Begin with the host name, then we have the type of the report, whether it contains the file interactions or internet history, and the timestamp when the report was generated. All right, and I mentioned that it is fast. So we tested Cider against a total of 5.9 GBs of Windows 10 and 11 Windows Search Index database files. And as you can see, it parsed it under 22 seconds. So yes, it is fast, and it will save you time in time-sensitive DFIR matters. All right, and if anyone uses Velociraptor or if is aware of Velociraptor in DFIR investigations, then we also have that functionality for you. It is available on our GitHub page or GitHub repository. And I would invite you to read the warning before using this artifact, because it is important to know how this artifact works before you use it with Velociraptor. All right, so let's see how Cider can help you in your DFIR investigations. You can even uncover a heist. So the files report will provide full path of the file with the modified access creation timestamps, as well as it will provide with the partial or full file content. Now you know someone bought private jets and Lamborghinis, and I want Lamborghinis too. All right, the activity history report. It will show you which user interacted with which file at what time, using which application, and the file in the question itself. You can even catch employees who search for their crimes online. How stupid is that? You get the title of web page or the website which is visited with the timestamp, as well as full URL of the website which is being visited. And like I mentioned, if there are any accidental malware downloads, or if there is drive-by compromise, you will be also able to enumerate that. If there is a new threat actor who does not know how to do anti-forensics, and if they search for how to do anti-forensics, Cider can also help you uncover that information. And lastly, for the internet browsing activity, if there is data exfiltration in question, or if there is sensitive site traversal in question, you may also be able to recover that, as Cider will recover the deleted browsing activity for you as well. And remember, I mentioned enumerating deleted file metadata. So we created a text file, interacted with it, and hard deleted the file, meaning that the file did not exist on disk anymore, and it was also not present in the files and folders report of Cider. But as you can see, we get the file name, when it was interacted with, the program used to interact with, and the user SID who interacted with that file. And you can see that we have two entries for the same file, meaning that the file was potentially interacted for 2 times. If you see 5 entries for a particular file, it can mean that that file was interacted for 5 times. So this information can be really helpful in digital forensic matters, and when a case goes to court. I don't think there are many artifacts which can provide you information in such granularity. So it's really amazing. All this is done for you. All you need to do is just parse Windows Search Index database using a very simple and fast tool. All right, enough with the boring part. Let's summarize what we talked about today. We talked about how you can enumerate files and folders present on a disk. We also saw that we can enumerate activity history or file interactions with current as well as non-existing files. And we can also recover current as well as non-existing internet browsing activity for all the users present on a system. All this from just a single artifact. And again, why should you use Cider? Because why not? It's fast and easy to use command line tool, which parses both Windows 10 and 11 databases at scale. And importantly, it gives you the analysis capabilities, meaning that most useful information is presented to you from the humongous data set. So you don't have to spend time extracting that information. It's all done for you in 3 beautiful CSV or JSON reports. And these are some questions which still remain unanswered, like, for example, what other user activities track, how big the Windows search index can get. We are still researching, and we would encourage you, if you work in DFIR, perform your own research. And if you fell asleep during my talk, which some of you did, don't worry, we have a blog post and you can scan the QR code. This blog post will detail all the information or all the points which I talked about. It's not a phishing attempt. If you do not want to scan it, there's a link you can visit right there. Right, a few folks, I want to thank Partha Akarli for supporting us in the research and Oleg Vitali for developing Cider. And quick disclosures or disclaimers, we used version 22H2 of Windows 10 and 11 to perform our research. If you do your own research, results may vary based on different build numbers. And this is my LinkedIn and Twitter. If you want to connect with me, if you have any questions, you are welcome. So thank you so much for joining my session.